Have you ever wondered how databases know exactly what data to show you and how to crunch the numbers too? In the next 15 minutes, you will learn how SQL filtering and aggregation work together to answer questions like which customers spent the most, or how many orders were placed last month. In this video, we will explore two fundamental concepts that are key to mastering SQL basics: filtering and aggregation. In case if you are new to SQL, we will start with a 2-minute refresher of the basic select from where query. Let's start with an introduction to the table that we are going to work with first. Think about an online store named the Sci-Fi Collective that sells only sci-fi products. Imagine that there's a table representing products in this database. There are 5 columns in this table, including product ID, name, description, price, and manufacturer. When the table is populated with data, it will look like this. We can ask a simple question that requires the help from a SQL query, like this. How do we get the names of the products that are sold at a price above $20? This query will help answer this question. Select a name from product where price bigger than 20. Then it's gonna be followed by a semicolon. You may notice that this SQL query has a lot of similarities with plain English. To be specific, SQL is like English, but with little to no small talks. But you don't have the same freedom in word choices when it comes to putting together a SQL query. You must use a set of SQL clauses, or known as statements. And you also need to follow some strict rules. In the query that you just saw on the last slide, you used the following 3 clauses. First, the select clause allows you to specify the columns you want to retrieve from a table. In this query, you only asked for the name column. As a result, the select clause was select name. Second, the from clause specifies the source that you want to retrieve data from. By source, I mean one or more tables. In this query, you only asked for the data from the product table. As a result, the from clause was from product. Third, the where clause allows you to specify the condition to filter the data retrieved by the select clause. In your first query, you only want the names of the products whose prices are higher than 20. As a result, the query that you put together was select name from product where price bigger than 20. Last, you should always use a semicolon to indicate an end of a query. The semicolon tells a database system that this is the end of a SQL query, and anything comes afterward will belong to a new query. That's a quick refresher of the SQL basics. Now let's dive deeper into the filtering topic. Filtering is a common data retrieval task. Whenever you need only a subset of data that meets some criteria, you will need the help of the where clause to filter the data. You just saw the application of the where clause in your first SQL query. However, it's worth to be more detailed in terms of what it means by a subset of data. To be more specific, a subset of data here means rows, a bunch of rows. The where clause filters rows based on the condition that follows. It doesn't care about the columns at all. Selecting which columns to include in the result is the job of the select clause. For example, if you want both the name and description columns in the result from the product table, you can list both of them one after another in the select clause and separate them using a comma, like this. In both of these two queries, the condition of the where clause is price bigger than 20. What if we have a different condition, such as products from a specific manufacturer, like Mad Inventors? To achieve this goal, we need to check if the manufacturer is Mad Inventors in the where condition. The query will look like this. As you can see, to check equality in SQL query, it's a single equal sign. You may also notice that the manufacturer name is wrapped up in single quotes. It indicates that this is a string data type. Does SQL have different data types? Yes. SQL data can be broadly divided into 6 categories, such as numeric data, string data, date or time, and more. In the product table, the data type of the price column is numeric. That's why you can filter price via the logical operators, such as bigger than or equal to. The manufacturer column, on the other hand, contains only string data, and that's why you can compare manufacturer to Made in Ventures Inc., and also why this string Made in Ventures Inc. needs to be wrapped up in single quote, which indicates a string. We will cover data types in the future in detail. Now that you know how to filter both numeric and string data at least, you can create one filter that combines the 2 criteria by using some logical operators, such as AND or OR. For example, to get products that are made by the Made in Ventures Inc. and have a price below 30, you can construct this query like this. The query says select a star from product where price smaller than 30 and a manufacturer equal to Made in Ventures Inc. The AND operator combines the 2 conditions. Only the rows meet both conditions will be filtered and included in the result, which means that the products that are manufactured by Made in Ventures Inc. and have a price below 30. By the way, the order of the result rows don't matter at all. You shouldn't have any assumptions or expectations in terms of how the rows are ordered in the results. The star here indicates all columns, and that's why the result includes all columns from the product table. If you want to select all columns instead of specific ones, you can always use the help of the star symbol. We touched on 2 concepts that are relevant to filtering, including data types and logical operators. Now that you have seen enough on filtering, we are ready to move to the next topic, which is the aggregation. So what is aggregation about? Aggregation is about performing calculations on a set of rows to produce a single result. By aggregating data, you can gain insights into the trend and the patterns in the data that may not be visible at the individual record level. For example, you may want to count the number of rows in the product table, and that will tell you how many products are sold by the online store The Sci-Fi Collective. To achieve that, you can write your query like this. Select count star from product if there are 10 rows in total, or say 10 products in total from the product table. The result will look like this. You may notice that the count follows by a bracket, which is used to wrap up the star. In other programming languages, this is a sign for functions. The same can be said for SQL queries. Count is a function that counts the number of rows, and it takes a single parameter. Regardless of if you gave it a star representing all columns or a single column like name, it leads to the same result because it counts the number of rows in the product table. Aggregation is about performing calculation on a set of rows to produce a single result, and the calculation rely on using some of the existing functions in SQL. Some of the most frequently used aggregation functions include count, sum, average, max, and min. As you can see, the names tell a lot about what they do. For example, AVG function calculates the average value in a numeric column. For another example, max finds the max value in a column. All functions are structured the same. The function name is followed by a round bracket. Most functions are only applicable to a single column with proper data type, except for the count function. Let's see a few examples of the aggregate functions to get a better sense of how they get applied. Think about we are still dealing with the product table from the Sci-Fi Collective database. Our goal this time is to calculate the average price of products that are made by Made in Ventures Inc. If you find this overwhelming, you can take a step back to get all the prices of the products that are made by Mad Inventors Inc., which will be translated to a query like this. Select price from product where manufacturer is equal to Mad Inventors Inc. The Mad Inventors Inc. is wrapped up in a single quotes because it represents a string. Having access to all the prices of such target products makes calculating the average price simple. All you need to do is to apply the corresponding aggregate function average to the price column in the select clause, like this. The result of this query will be a data point in a single row and a single column, representing the average price. Its column name by default could simply be count bracket in many database systems. If you don't want to settle with the default column name, you can use the as clause to rename it, like this. And the result looks like this. As you can see, the name up to your choice that follows the as clause will be used to name this column. Let's look at another example to learn how to perform aggregation by groups. This time, our goal is to get the number of products per manufacturer. This goal requires us to group products by manufacturer first before counting the number of products per group. To achieve this goal, we need the help from a clause we haven't seen yet. The query that achieves this goal and the result are presented here on the screen. The result is literally product numbers grouped by manufacturer. This query is using a clause that we didn't cover in the past, which is the group by clause. The group by clause in SQL is used to group rows that have the same values in one or more columns so that you can apply aggregate functions to each group individually. In this example, we grouped the rows in the product table by manufacturer. After that, we applied the count function to count the number of rows in each group. That's why this query helps us achieve the given goal. Now you know what group by does, and how it is used in concert with aggregate functions. Let's talk about what you need to pay attention to when it comes to aggregation by groups. First, the group by clause is rarely used alone. It is used with one of the aggregate functions. In such a case, you need to remember to include the column followed by the group by clause in your select clause. For example, in this query, as you see here on the screen, we group rows from the product table by manufacturer. So we need to make sure that the manufacturer column shows up here in the select clause. Why? If you forget to do so, your result will become something that's very difficult to interpret. For example, you may forget to include the manufacturer in the same query that we just covered, and you will get a result looking like this. What does the query do? The query still does the same thing. Group rows by manufacturer and then count the number of rows per group. However, when you forget to include the manufacturer as a column in the select clause, the manufacturer information won't show up in the result. So the product numbers per group is kind of pointless standing by itself. Okay, that's one of the important things about the group by clause. Another important thing about the group by clause is that you need to remember to exclude any irrelevant columns in the select clause when you are doing aggregation by group. Specifically, you need to exclude any columns that are neither in the group by clause or the aggregate function. Otherwise, SQL will complain. For example, when you try to add another irrelevant column to this query, like the name column, you will get an error message like this. When using group by clause, you need to make sure two things. First, you need to include the grouped column in your select statement. Otherwise, you may end up with a confusing result. Second, you need to avoid selecting columns that are not in the group by clause or inside an aggregation function. Otherwise, SQL will throw an error. In case if you wanted to run the queries that were covered in this video and replicate what you saw, you can find everything you need from this GitHub repository. The URL of this repository can be found in the description of this video. The easiest way to replicate what you saw from this video is to load data into a tool named SQL Online. You can follow the README files in each of the corresponding folders, for example, Chapter 1, to see the detailed instruction. Of course, you can follow the instruction to install your preferred database system locally and then load the scripts. But we are going to simply use a tool that makes things easier for us to start. The tool is named SQL Online. Essentially, that's a SQL database system running on the cloud. Once you follow the instruction in the README file to load the corresponding script from what we prepared for you, you will be able to run all the queries that were covered in this video and see the same results. Let's quickly recap what we covered. We started with a very basic SQL query, and then explored two fundamental concepts based on that, filtering and aggregation. If you find this video helpful, give it a thumb up, subscribe, or drop your questions in the comments. I would love to hear what's working for you and what needs to be changed. If you wanted to go deeper into database design, this video is based on the book Grokking Relational Database Design, which walks through these ideas step by step with real-world examples. You'll find the link to the book in the first comment.